All right, so thanks for joining me. Today we're going to talk a little bit about GetInventory, a script that I've created to really help a lot with assisting network engineers with gathering multiple commands from devices, from a series of devices, and now I've recently added some features that allow us to parse most of that data out into tables, which makes this tool exceptionally useful and exceptionally powerful. So GetInventory really is going to help you to kind of optimize your workflow, again, with regards specifically to just configuration gathering and being able to understand the data that was pulled out from a configuration. I guess I should preface and say the tool is pretty specific right now to Cisco iOSs and NXOS. However, it will be expanded to other platforms in the future. The tool allows us to really reduce human error. It allows us to do a repeatable, consistent process, not only with ourselves as individuals, but also with throughout our team, with our teammates, to ensure that everybody's taking a similar approach with, what data are you gathering, how are you storing that data, making the data accessible, and again, just ensuring that everyone's kind of following the same data collection process. Again, recently some features have been added. A few parsing tables were originally part of the tool, but that's really just completely blown up just due to a new feature that was added that allowed us to add all kinds of new parsing tables. We'll talk about those in a little bit more, but also you're really just going to be able to kind of simplify your life. This allows you, you got a collection activity to go do the collection activity in the background while you're doing something else, and then again, have just a consistent approach, so that will help you, between device 1 and device 10, making sure that the data that you're looking at is consistent, that it's being delivered consistent, that it's all in the same format for you to be able to parse through and actually analyze that data. Last but not least, I think this is a good opportunity always to kind of impress your customers with, access to tools, understanding the tool set that you have available to you, and you'll see this tool is out on the internet. You can go grab it. I mean, your customer can go grab it. There's nothing stopping anyone from pulling the tool down. And not only giving them the data report in and of itself, but also how easy it is to use and how easy it'd be for your customer to use it in the future. So some of the use cases, at least that I've seen, and I think we have a lot more potential here, but definitely configuration backups, just something as simple as grabbing the configs or grabbing point-in-time data and storing it over a series of devices, grabbing those time shots, whether they're daily, weekly, monthly, just to be able to have them as a repository of here was the state of the network, here's how the network changed over time, kind of outside of your normal configuration backup tools. The EOL replacement, I have a couple of teams that are doing that do a lot of their discovery work, as well as any pre-migration and post-migration is actually requires them to do a snapshot with the tool. This allows you to do comparisons between, even next week somebody calls and complains about a MAC address that's missing off of, or a printer that's missing. You track down the MAC address and you find out that wasn't even connected to the network prior to your implementation. So it really helps you kind of get a grasp of the environment, and makes it real easy to even kind of spread your sample size. So you're not just looking at the 4 devices that you're touching, but go ahead and pull configs for the other 10 devices that sit around that, so that if there is any type of a domino effect or relay effect, that you actually catch that. On some of our network assessment processes as well, projects, we're also using it for discovery, configuration backups, pulling down route tables, any type of really analytical data that needs to be pulled for assessment. And then that leads us ultimately to the network analysis, where discovery right now is a big piece, but we're basically saving some future use cases of having that raw data to then be able to use other applications to basically go run by the raw data and do some advanced analysis with them. So the workflow all starts and ends in Microsoft Excel. Hope you're used to Excel, but no formulas here, really easy to work with. It's just more of a format for you to kind of put the data in and store it. The obvious things, the host IP addresses or DNS names need to be added. You can put in username, passwords, output directory, output file names, etc. Some of those features you can also put in from a command line as well. So if you don't want to put them in the Excel spreadsheet, or if you have a reason not to or want to launch them at the time as opposed to going back and changing the spreadsheet. So the spreadsheet, you're going to launch it via the command line. There's a default file that is actually included in the download off of GitHub. You can launch directly from that file with no arguments whatsoever required, as long as you put all the details in that you need. Or if you actually provide some command line arguments, that works as well. The switch to pull up the help menu is -H. So the arguments, you would run the Python file space -H, and it would show you what the available options were. So once that happens, the script is going to log into basically every device that's defined in the spreadsheet on the main tab. It's going to cycle through each single device, type a bunch of commands, parse that data into the spreadsheet so that it's in a spreadsheet type format where you can use filters and pivot tables or charts or whatever else that you might think about using. In addition to that, there's a command output file. That command output file has a list of commands that the user of the tool actually specifies. So again, you can just put in kind of a wild list and let it sit there and cycle through every one of those commands, grab the command, put it in a text file. And then in addition to that, there's also a JSON output file. We'll talk about that in a little more detail, but effectively that's for some future use cases. But we're basically pulling some of this data back in JSON format, so it really just gives us an ability to kind of snapshot the data, put it in a text file so that we can write some other applications that will then use that JSON output. But it is interesting. If you're interested in JSON, there's some good JSON output there as well. So talking about what does GetInventory do, the biggest thing that it does is over on the left side is the command parser functionality. You see a list of commands here. There's a handful more commands, and probably by the time you even read this, there will be even more commands that are added. But for almost every one of those commands, there's either a tab in the spreadsheet or the data is included on the main tab. You can think about it like this: if the data is able to be presented in one line per device, then it will be on the main spreadsheet. If, however, there are multiple lines, think about things like interfaces. Those will be pulled over to another tab where you'll actually have a list of all the devices in the spreadsheet and then a list of every interface for every device. So we'll talk about those in some great detail whenever I show you kind of in the second half how we actually execute the tool and what the data looks like. So in addition, we have some additional features, not really all features, but the command list to an output file. So here again, in addition to this command parser, if you want to just put in your own commands, so an example is right now there is no voice parser, so maybe you want to type some show voice commands. Show platform, show really whatever that you're looking for that's not really included in the default command parser, you would want to put in that command list, and it'll just cycle through for every device, cycle through every list, every command in that command list, and put it all in one single output file. Again, the JSON's future use case, won't talk too much about that. We do have command line support, talked about that already, and then also in the future I'm looking to add jump box support, so you can actually bounce this off a third-party jump box, and definitely we're looking to add multi-threading so that we can actually ramp up the performance time, just because natively SSH and Telnet are slow. So in order to get started, it's really easy. If you already have Python installed, and I guess I should put a note there, this requires Python 3.6 or above. But if you don't have Python, go download Python. And then what you want to do is you want to go to GitHub. Here's the GitHub repository listed here. And pull down either a download of the zip file, or if you're using an application to pull it down, you can actually clone the entire directory. So within the directory, you're going to find basically the main script file. This is where all the guts of the script are. There is a requirements.txt file, which we'll talk about that here in a second, but that allows you to easily install the library dependencies. And then there is a sample Excel spreadsheet called GetInventory-default. This is basically set up for the program is ready to use this spreadsheet. Actually, if you don't provide any command line arguments whatsoever, the program will look in the local directory for that file and will attempt to execute the data that's in that file. Last but not least is one of the things that allowed the JSON parsing to work so well is a product called TextFSM, which was actually included in NetMiko, which is our SSH telnet library. However, in this instance, the TextFSM is actually directly included in the library, but we actually have to pull the templates down separately. And not only do we pull them down separately, but also I've learned I have to make changes occasionally to these templates. They're not in the best shape that I've ever seen for kind of primetime templates, so I'm having to massage them to actually make them work. So basically, this is our own custom copy of the NTC templates. So with that being said, I have a duplicate there. Let's actually go ahead and go to the install, and I'll show you how this works. So if you start on your web browser and go to github.com/tc45/getinventory, it'll take you to this page here. Over here on the right, there is here's the list of the files we just saw. So the directory NTC templates, the GetInventory default.xls, the Python file itself, and the requirements file. And if you want to look at the Python file, you can click on here and go look through here at everything that is in here. And I'm not the best coder, but there's nothing that you'd be surprised about here. We just log into open up the spreadsheet, pull the list of devices, log into each device, run through the set of commands. It's fairly straightforward. And then the requirements, if you take a look at it, we actually have two requirements right now. So NetMiko 3.0 and then OpenPyXL 3.0.3. OpenPyXL is what allows us to read and write from the Excel spreadsheets. So from right here, if we click on clone or download over here, and there's an option to download zip. Let's just go ahead and do that. I think that's the easiest way to demo it. It'll download a file to our desktop. Open that file up. We'll get the directory, the master directory output, and then basically here's the list of the files that we just talked about. So the Python file is less than 100K, and the spreadsheet's pretty small right now, just 25K. So I have, let's go ahead and, what did I do here? We create a folder, temp, let's create a Python scripts, and let's create a GetInventory. You can call the folder whatever you want, doesn't really matter, because you're actually going to be launching everything locally from within there. So once you have it, copy all the files into that folder itself. Should look something like this. And then you'll want to open a command prompt. I already have the command prompt open, but so let's go back there, cd temp, cd python, cd get, and just to double check, I'm just running Python. You'll see I'm running Python 7.3 or 3.7.4. So back from the command line, what you want to do is use your pip installer to actually do the installation for the requirements file. So in this case, if you just type pip install, and I think we -r requirements.txt. I believe is the command. We'll check here, but it should at this point reach out to the internet, go grab NetMiko, and go grab OpenPyXL and install them on my computer. And that is what it did. So there you go. You see there's some other dependencies that got pulled down, cryptographies and Paramiko, serial, SCP, etc. But you know, again, because even text to FSM is right there. But because we used our requirement file, it was all just downstream included in the install. So just as easy as that, the application's installed. There's nothing else you have to do there to get it installed. So let's take a look at the actual file here, GetInventory file, and see what we have going on. So right now the file is pretty blank. I actually have a username, password, and a secret up here. I'll go ahead and enable editing. Change those to whatever your username, password, and secret are. By the time you actually probably see this video, we will have these fields hidden, so your password will not be shoulder surfable, but do keep in mind that Excel is not a secure medium to keep your passwords long term. So that's also why we'll be offering the ability to pass it in at a command line, and also to prompt at the command line if you don't specify the password. But so you also want to specify an output directory. So just for grins, we're actually here. Let's go back over there. We're going to delete this entire folder structure, and I'll show you how this works. But basically, the folder structure is going to get recreated. So I'm just going to delete this GetInventory folder. We're going to put it in a folder called lab test, and then this is the first run we're doing, and then the output file name is going to be called lab testing, and then it'll actually append the .xlsx. So at this point, all we really need to do is actually put in a list of hosts here. So I have some hosts on an EvenG server that I'm going to use in this demonstration. And a couple of them are iOS, and then a couple are actually NXOS, so we have a little bit of variability to see between those two platforms that I'll be able to show you here. So so once my devices are listed in, and even a couple of these there is no device for it, so we'll even use that as an example to see what happens whenever a device can't be contacted. But so I know the first two devices are iOS devices. The next two devices are iOS or NXOS devices. So I want to go ahead and change those to NXOS. Actually, you know what? I'm going to use one of them as NXOS, and the other I'm going to show you a feature that's called auto detect. But what auto detect will do is attempt to actually guess what the OS type is, and then basically restart the connection with that connected parser. If you do not specify a parse method, it defaults to Cisco iOS. That's the first one that it tries. So it's faster if you just let it default to iOS as opposed to do the auto detect. If by chance you needed to run Telnet, or you needed to override the protocol, the port number, so if you needed to connect to port 2222, you could actually specify these here on these fields. And whatever, you know, the line, whatever the host, that port will be appended to it. In this case, we're connecting all to port 22, which is considered the default, so you do not have to put anything in there. So just to kind of walk you through, here actually I'll tell you what, we're going to save this real quick. Well, nope, so no, one other thing. We're going to go take a look at settings real quick. So if you click on the settings tab, just kind of a quick list of the different options that you have. So do you want the version information, ARP, Mac, interfaces, etc. And then most importantly, this one, because we want to demo it, is gather commands. So let's go ahead and click that on yes. So now it's actually going to attempt to gather the list of commands that's on the commands tab for every single device that's on the main tab. So go back over to commands, and you see here's a pretty significant list. There's 29 commands that are on that list. So everything all the way down to the show logging should be gathered for every single device and put into its own unique independent file. So let's go ahead and save this. Again, this is all really that you need to put in, is this little subset of data right here, and you're ready to go. So I'm going to go ahead and close the file here. We don't need it. I'm going back to my command prompt, and I'm going to say Python main.py. And again, because I'm using the default Excel spreadsheet, I don't have to specify anything on the command line. I can just press enter and it will start the process. So we're going to see there's a lot of debugging that I have turned on right now. Your version probably will have less, but you'll see basically what we do is we go to the spreadsheet, we find the list of devices. From the list of devices, we look at the commands, we get the list of command tabs on the command tab, and then we start logging into every single device one by one, and then going through typing the integrated commands that me as the developer has put into the application. But also what you're seeing right now is typing all those individual 29 commands for every one of the devices. Now this part of the command output, to let you know, is not there's no discrimination between routers and switches and firewalls. Everybody gets the command. So sometimes the commands work, sometimes they don't, but the point is that you at least get the opportunity to scrape that data for every single thing. So we've already flipped over to device number 2. We're on .129 right now. And you'll see we'll keep cycling through these over the next minute. But what I'm going to go ahead and do is flip over and show you what the output looks like. So a couple of things. One is we're sitting here in the C directory in the temp folder, and I'd previously deleted the GetInventory folder, but it actually recreated the GetInventory folder, also created the subdirectory lab test, also created another subdirectory run1, and here you go. Here's the output that we have so far. So you'll see as this completes, more and more things will start popping up. But let's go ahead and take a look real quick. Let's just look at CR03 commands. So if we open up this file, that's what we actually already have. So start at the top, tells us the device that we're connected to, has the list of commands that we're going to run, and then every command is basically executed and then shown per section. So show clock, show IPnt brief, show run till however far down show run goes, show into script, protocol summary, etc. So on and so forth. So these become your reference point that you can always come back to. At this point, I no longer need, from a discovery perspective, I no longer need to log into the client network to go figure out what piece of data I need. I have it all in this one document right here for me. So as we sit here and let this go, you'll see device by device, and I think there's only 5 total devices that we're going to pull back. But one by one the devices will come back. Actually, let's pop this one up. So this is CS06. You'll see this is an NXOS device, so even though it's a Nexus device, most of the commands still are going to run exactly the way they do on iOS. However, you do sometimes have, I don't know that I have an example here, but sometimes you do have some commands that are supported on iOS but not supported on NXOS. But for this part of it, this doesn't really matter, because again, all we're really looking at is just getting these commands in a raw dump type format. So I talked earlier about the JSON output, and just to show you kind of what that looks like, is basically every one of the commands that the program types, that's integrated in the program, that data is then stored in a JSON format. So I go ahead and extrapolate that data and pull it out. But you see here we get show version, show BGP. I've got a big BGP table here. Goodness, a really big BGP table. Network table, so this is your standard routing, show IP route table, and you'll actually see in this instance, well, I had something not quite work right that I'll have to look through, but one way or another, in this instance, we got the global routing table here, so we at least got most of the data. we're almost finished up here. If you just bear with me just a second, and we'll get back to what that final output file looks like. I believe we're on the last device, .132. And just to reiterate, as this is kind of finishing up here, let me log into one of these devices. You know, this is really the bread and butter of what this application is doing. Is, you know, it's taken this raw data here, like show CDP neighbor detail. That's kind of very difficult to read. It's difficult to parse. You know, it's hard to break this out into any type of usable format. And we're actually taking that data, pulling it all out, and then actually parsing that data back. So again, if we, I'm not quite finished, but we're going to go ahead and jump ahead here. If we open what the output, I'm going to start with the CDP data, but you look at CDP. So again, this could be what you're looking at, but instead you're going to be looking at this. So, you know, here we have by device. So in this case, you know, CR03, we have a list of all the CR03 devices, the interface that it's connected on CR03, the remote host that it's connected to, the remote port, remote IP. If there is a management IP being advertised, we grab that. That's kind of unique to iOS platforms, I've learned, and XOS doesn't support it. Software versions, etc. So all that data that normally you would have to page through pages and pages and pages of data, I basically have a look at my entire site right here with just a, you know, almost a single pane of glass. And the same thing goes for, you know, the inventory tables. So the hardware inventory, the I must have interfaces turned off, but the route table, the BGP table is all pulled out. We have great AS path information over here. CDP, we got our LLDP if you are running LLDP, so that I got two devices that are running LLDP, but those are enabled. Your ARP tables, MAC address tables, and then if you do run into any errors, I actually pull some of the errors here, so I'm not sure exactly what all those errors are for. Some of them are kind of normal errors, so like if a router tries to type in the command show MAC addresses, it throws an error. So we just capture some of those errors. But other than that, yeah, most of the errors should be pretty self-explanatory. But anyway, so that's it. Other than, I guess I should say, that's it with regards to the parsers on the individual tabs. But then you come back to the main tab, and we actually have a lot more data out here now. We've done a little bit of determination, fingerprinting to determine is it a router or is it a switch. We've grabbed host names, some model numbers, serial numbers, went through and looked at some uptime data, iOS version, and then this is a lab instance, so I actually, I have the interfaces turned off. That's what happened here. I was making a change that yeah, so normally this interface parser would actually populate. I'll actually give you an example real quick. So the interface parser would normally look something like this. So you'd actually have a kind of a complete list of, you know, how many Ethernet interfaces, how many of them are active, how many are gig, how many are active, 10 gigs, 25, 40, 100, how many sub interfaces do you have, tunnel interfaces, port channels, loopbacks, VLANs. We also pull down some CPU statistics for just easy access. And then this hasn't actually been fleshed out, the SFP counts, but we will be adding some SFP counters here. So all that being said, that's pretty well about wraps it up.